Hello everyone. The aim of this video is to present you the motivations of the class BP13. I will also give you the aims of this lecture, and I hope this will be appealing to you. So BP13 or BP13 auf Deutsch is basically called Grundlagenwissenschaft, Programmierung und Modellierung. In English, it's simply translated as basic programming and modeling. And here I subtitled it for geoscientists. So the aim of this course is basically to introduce you to programming and modeling, but we will have a focus on geoscientific applications during the course. So, as I stated already in the previous lecture, here the main language of interest will not be either the spoken German language or spoken English language. The language of interest is the language you are going to use to interact with a computer. And during BP13, the language of interest is going to be Julia. So Julia is a recent open source language. It's really accessible to you, and it has the particularity to be fast. It's spreading quite fast in the geoscientific community, so it's being used more and more. And this is the reason why I have selected Julia as the language for our course. So, why did we design such a course? You're all students in geoscience. This means that you have to deal with data. On the one hand, as a geologist, you should be doing some field work, you should be analyzing the landscapes, analyzing the rocks, bringing rocks to analyze in the lab. From lab analysis, you will also produce some data, and you may at some point want to conceptualize and start building models to explain your observations. So in geoscience, we are at the interface where we need to work with field data, laboratory data, we need to develop ideas, concepts, and theories. So that's why there is a need for analysis of data, modeling of the data, and of course, you will need to visualize the data. So most of the applied research activities in geoscience will require some form of computing. You will need to use a computer to do this task. So it's useful to learn the good practice of computing, and I'm convinced that the best way of doing this is by doing practical analysis exercises. So if you wouldn't be using a computer, then it would be a lot of work. So if you just want to use papers and no computer, and you may end up in a pile of data like this poor lady down there, and it may become difficult to organize everything and analyze everything. So that would be a lot of work. The aim now is to replace these paperwork by using a computer. So the computer is supposed to be your friend, and it should be efficient at doing tasks automatically. The tasks that you're doing, they should be portable. So if you change one computer or if you send some script to a colleague, your colleague should also be able to use it. The results of the analysis should be reproducible. So if you run it one day, 1 week later, if you run again the analysis, you should get the same result. And you can also obtain good-looking results. By good looking, I mean nice visualization of the results you obtain either from the field, laboratory, or from theoretical modeling. So that's what we are going to do in BP13. We are going to compute. And there might be a hidden explanation, is that once you want to get rid of too much paperwork, or you don't want to repeat analysis, you basically want the computer to do it yourself. I mean, that's also part of human nature. If we have the tools not to, or to relieve us from working too much, then we will be using that. So we are a bit lazy by nature, and this is why the computer will be our friend for this course. So this is how you can imagine now the lecture. We will have data on one side, and we will need to exploit this data or these theories. And to do this, we're going to use the computer. The computer will be the main tool for analysis, modeling, and visualization. More about why we would be running such a course. This is a sketch from the Frankfurter Allgemeine Zeitung, and this sketch dates back from 2001. Basically, it was published as to argue that there is a need for digitalization in administration. So you see the poor guy sitting on the chair is basically hitting on the mouse with his knuckle and is trying to stomp a screen. So basically this is showing that the use of the computer is basically not something the person is used to. And in fact, we are now more than 20 years later, and at least in the administration side, we are very far from being, from having reached goals of digitalization. So any student now in the university should be learning good practices, basics of computing. So even if you don't continue in geoscience and you go in another branch, anything you would learn related to computer programming will be useful for you in the future. So this is the preliminary schedule, actually not so preliminary anymore. The course organization, you're already a bit familiar with this. We will have flipped classroom. So I will provide you videos. The videos are available on the YouTube channel right there, and there will be one playlist dedicated to BP13. And we will have weekly appointments on Zoom or either in the room. You can see on OLAT for the details of the appointment. At the end of the course, there will be, of course, an evaluation of your performance, and this will be based on 2 grades. There will be a report, so the report should be no more than 5 pages, and there will be one exercise. Basically, it will be one notebook. Remember, last week we saw how to create a notebook. You are going to be using a notebook for the exam. So these are now the 3 main points of BP13. As I told you before, we want you to get familiar with basic programming. We want you to be able to handle and visualize data. And you should also receive some basic elements of modeling. And since I'm expert in geodynamic modeling, I will give you some geodynamic modeling notions at the end of the lecture. But don't worry, it will be all very basic and reachable aims. So the focus of the lecture is set on applied examples and exercises. in the first part, getting familiar with basic programming, we will learn about the basic structure of computers. So we'll discuss about CPUs, GPUs, memories, drives. We will talk about programming languages, compiled languages versus interpreted languages. We will make an introduction to programming. So we'll discuss the types of data you have in the computer, loops, if statements, functions, vectors, arrays, matrices, and so on. So that's the first third of BP13. In the second part, we will start handling and visualizing some data sets. So we learn about reading and writing data to disk. There will be some examples of data treatment, filtering, sorting, modifying data, and creating some graphical outputs. That's an example of one exercise we do in the lecture. You will read a digital elevation model, so it's a topographic map, and you will learn how to visualize the topography, but you will also compute derived quantities from topography. For example, you will compute and visualize the slopes, and we will extract some topographic profiles and plot them on different lines. So that's one example. A second example that we also may meet in this BP13 is reading chemical data acquired at the microprobe. So that's basically a mica schist with garnets, and you will learn how to plot the data, how to identify some mineral phases, and how to compute phase abundance. So you will be basically reading a thin section. In the last part of the course, you will receive some basic elements of modeling, and more particularly geodynamic modeling. So there will be an introduction to the finite difference method. This is a way to discretize ordinary differential equation, ODE, and partial differential equation, PDE. Don't be afraid at this stage. We will go very smoothly with all of that. One example of exercise will be we'll be solving an ordinary differential equation here. That will be applied to the radioactive decay. So we will study the case of a single decay and the chain decay. So for example, here you see the decay of uranium-234 to thorium-230 to radium-226. This is a chain radioactive decay, and you will learn how to model that. Another example is the propagation of seismic waves. As you know, when a fault is seismically slipping, wave will propagate from the fault zone, and we can actually simulate the effect of wave propagation by solving the wave equation. So that's a partial differential equation, this type, that we are going to solve in the course. And you will be seeing movies of how waves propagate in rocks. So that's it for the introduction to BP13. At the end of BP13, you will have received all the different elements I mentioned before. So I'm looking forward to continue this course together with you, and thanks for your attention.